Hello, in this video we are going to form the acute angle formed by the two main diagonals of a cube. I've got over here a sketch of a cube made with GeoGebra. You can see over here my cube has a length of the edges 1 unit, but this is not relevant. I just made that picture. And I'm showing as well the main diagonals, for instance, the diagonal going from the point E to the point C and from the point H to the point B. I want the acute angle between them. So let me mark over here where they meet. Here they meet, and I can see the angle over here. And well, GeoGebra is already telling me how big that angle is, but actually we want to do that ourselves. So let's see how we do this. I'm going to look at the rectangle formed by the points E, H, C, B. I'm looking at this rectangle that cuts my cube in half because my diagonals live there. Let me sketch it over here. E, H, CB, not to scale, of course. Let's say BC is an edge of the cube, so this has length S. And then we have the diagonals EC and BH, and this is the angle alpha we are trying to find. So there are different ways of doing this. I think at this point you should pause the video and try to do it yourself and see what you come up with. This is one possible solution, not the only one. I'm going to say that the length of this side EB is T. T, you see it over here, this segment on the cube. This is the diagonal of one of the faces of the cube. So I'm going to draw the face of the cube over here, length S, and then we have the diagonal D, and this is a square. And we are trying to find D, so we are going to apply Pythagoras and say that S squared plus S squared is equal to D squared. So D is the square root of 2 times S squared, which we can write as square root of 2 multiplied by S. Okay, so I'm going to consider the following triangle over here. This triangle is right angle, so I'm dividing in half the triangle where I see the angle alpha I'm trying to find. So this angle over here is alpha divided by 2. This leg has length S divided by 2, and the other leg has length S square root of 2 divided by 2 because it's half of the face diagonal we just found. So now with all this information, we can apply trigonometric ratios to find the the measure of the angle alpha divided by 2. So we can say that the tangent of alpha divided by 2 is equal to, opposite, we have the side with length S divided by 2, divided by adjacent is square root of 2 over 2. To divide fractions, we need to multiply by the reciprocal of the divisor. So 2 over S square root of 2, the S simplify and the 2 simplify, and all of this is just 1 divided by square root of 2. So with help of the calculator, we could find half of the angle alpha as the inverse of the tangent of 1 over square root of 2. And then the angle we're trying to find is going to be 2 times this, so 2 times the tangent of the inverse of 1 divided by 2. Let's see what our calculator says about this. Here, yes, that is 70.5 degrees to 3 significant figures. So we found the angle we wanted to find.